Okay, doke, I'm back. Ah, I fucking was doing push-ups or something at work, and at some point, my wrist just became real, just tender. If it's doing like, oh, any force pushing it inwards like that, push-ups hurt now. Strength is there, but just oh, it just hurts doing that. Checking, dude. There's no music in this. What the fuck? Okay. Oh yeah, I wasn't even doing glasses. That's kind of why the font looked a little funky. All right. So I'll do that again in a sec. What will I do? So we're gonna do using the limits to ignore to get input for what? Calculator's all cool. What else? Trying to think of cases where we're getting input of one type using standard character input and then using it again, but for another type. And we want to ignore the input to avoid it trying to be extracted to something else and then character input failing because it won't just clear it, it'll only clear white space characters. So, what is a case where we would do that? We could do. Oh, I was thinking targeting an enemy, like choosing which enemy you're gonna attack. But then you'd be doing. We could do that, and we could say which enemy A, B, or C. Because I was gonna say you type in the name, but then that's different because we would be using standard standard character input or standard get line, which uses standard character input, but then it kills white spaces and gets the whole thing, gets the whole line. So stores all of what a person enters. The whole thing is a string. So in this case, we could do we'll have a program. Excuse me. And we want to do what? So we want to get input to say who are we targeting, and then we want to pass that to an apply damage function that just damages that enemy. So what are we putting? We're putting in that, and then we're putting in. But in that case, we're only saying who we're targeting. Like in a game, a turn-based game like Pokemon, you just say, "Hey, I'm attacking," and then, oh, like which attack do you do? And then you have 1 through 4 attacks, and then you have which enemy. The enemies are A through D. So you'd call attack enemy. Gotcha. And the test would be which attack or which enemy and then which attack. So attack enemy would have a couple different functions. It's a helper function to put them all together instead of having to call them individually. And it would say, okay, who are you attacking? What attack are you doing? And then it would take those values, and one would be an integer, which attack. One would be another. Oh, and then we would make sure that those are valid. So if it's between 1 and 4, so there'd be a check to make sure that the enemy selected is valid. Check to make sure, because let's just pretend there are 4 enemies and you have 4 attacks. And then, and we could have a variable set to be, hey, this is how many enemies there are. So we could update that global variable too. Yeah, that could work. So we could say there's 3 enemies now, and then now it's whatever. Or oh, well, I guess it wouldn't work. No, that wouldn't work as well because then we'd say, because we have cases, so case A, B, C, D, and if we remove an enemy, then we need it to automatically update. In that case, then it makes more sense to just do an if statement. That way we don't have to update the case, because then all you do is update one variable. Hey, is it less than this number? Or less than or equal to this number, and the number is the number of enemies. That way the if statement automatically adjusts. So we have a global variable for the number of enemies, a global variable for the number of attacks, and then instead of switch cases, we'll just do an if statement. That way we can change them for how many attacks you have. We could do... It seems like we don't really... It seems like an if statement is just more convenient here instead of a switch. Oh, and the reason is because... let's see. Yeah, the reason is because we're doing whatever the attack is. We're not actually calling different functions. Like, there'd be a bunch of different functions for each possible attack. And then we say, in getting the attack, I think an if makes the most sense here. Okay. So, we're going to we'll have attacking, targeting, character stats, say how many, well, what are we doing? We're doing, yeah, we could do that. We could do world stats, like, yeah, I think that makes sense. Okay, so first I'm going to do a header file, and it'll be, it won't be constant because the number of enemies can change, and the number of attacks the character can have maybe can change too. So we can say that. So we'll just say, what would be the value of doing, I could just make it inline. I think that might make sense here. Fuck it, we'll just do that. So we'll just do world properties. And this will have an integer for the character, and it'll be character attack count. And we'll just say that it's 4. Character has 4 attacks by default. Okay? And then we'll say integer current enemy count. And maybe this gets updated every time there's an encounter. So you could have an encounter, and then encounter updates it, and then blah, blah, blah. You could change it each time. So we'll just say there are 3 enemies. 3 enemies in the encounter by default. And these are just going to be inline. The difference, though, if it's inline, it has to be included. There's no CPP file, so we include it in all the places we're going to use it. But these other files that we're including are going to need it, and I don't want to include everything. Well, either I include the for declaration or I include them and just make them inline. What's the difference there? Maybe the for declaration makes sense. So we're just not gonna... I'll just make these extern. Okay. And then we'll have world properties. And then we'll include world properties. Namespace world properties. And it would make the most sense to just copy those over, but copy the whole. I mean, maybe that makes the most sense. I won't do it here though. Okay, character attack count. And we'll say this is already extern, so it doesn't need it. Okay, character attack count by default is 4. Oh, actually we would want, you know what, I'll do it in this case because I already had these comments which had the values. So we'll remove extern because these are the 4 declarations, not these. So the character by default has 4 attacks. By default there are 3 enemies in every encounter. Okie doke. Don't need anything else here. All right. And we'll say we don't need to include world properties in main, I don't think. Now we'll say enemy targeting or player targeting. I guess player targeting makes sense, or player attack. So what do we want? We want to choose the attack and choose the enemy to attack. Yeah, I guess that makes sense. Player attack. Yeah, we'll just say that. If not defined, player attack, then we want to define it. That way it can only be included one time in any given file. We'll end the conditional preprocessor directive here. And we'll say namespace player attack. Anything more specific? Player attack? We'll just say player attack. That seems fine for now. And so we'll say we want to get which attack to use. So we want to get an integer from the player. And then player attack needs to be valid. And then, yeah, so we could just make these always valid. Yeah, it makes sense. Okay, cool. So we'll say there's going to be an integer one, and it's going to be called player attack choice. Which attack are you going to use? No parameters. And then we'll have a character, player enemy a choice, player enemy choice. Which enemy to attack, which attack to use. Attack to use. And we actually want this to be in opposite order. Oops. Okay. Alright. We also want just player attack. Or, yeah, we'll do that. We'll just say player attack. This is fine. Void player attack. This is a helper function. Okay. So this will be called, and then it'll say, okay, which enemy, which attack, and then it'll output the information. Okay, I think that makes sense. And we'll have player attack. Cool. All right. And so we'll do first player enemy choice. This needs world properties. Needs player attack count and enemy count. What is it called? Just enemy count? Current enemy count. Okay. And so we'll say there's a character and it is enemy choice. So this is which enemy the player will attack, and we will assign it using a do while loop to make sure that it's a valid option. And we could update this. We could update world properties, and this would constantly get the valid information. So if we update current enemies to be 2, you've killed an enemy now. Well, this will only allow you to choose enemy 1 or enemy 2, because there are only 2 enemies now. So we could say get character. We could say, do I need a generic get character and get integer? I don't think so. We'll just do, oh, we do want to ignore though, ignore line, so we could have an extra thing. Yeah, so we'll do call it? What do we want to call the ignoring line? I could just put it in world properties, but that doesn't make sense. We could do tools, but CPP tools. Yeah, we'll do that. Okay. If not defined, CPP tools H, define CPP tools H, and if cool, and we'll say void ignore line limits needs standard numeric limits to get the max of a stream size, so we can clear the input buffer. Okay, ignore line, and then we'll have the implementation CPP tools includes CPP tools clears input buffer until that character. Okay, and what does it do? Ignore line will simply standard we need to include this in CPP tools, so we also need to include IOStream, need standard character input dot ignore to clear or to get the input buffer info, or to access the input buffer. Okay, so we'll say standard character input ignore standard numeric limits, and it needs standard stream size, which is the type of thing that it's getting something about. In this case, we're getting the max of it, and we're going to ignore until the inline character. Ignore up to a whole stream size until we find that character. And technically this is ignore until this. Or clear input until that character. Okie doke, and honestly this probably makes sense to just put right here. Oops. Okie doke. And then in player attack here, we can just do which enemy or attack which enemy. And then it could have a loop to say each enemy. Attack which enemy. And then it could say for int current enemy. Yeah, we could do that. Current enemy. And then, so there's, we'll say it starts at, okay, please. Why? We'll say we start at 1. And then we go up through however many enemies there are. Current enemy. While current enemy is less than or equal to world properties, current enemy count. So while it is less than or equal to that, and then after we will increment that, and all we're going to do is we're going to say so we'll say current enemy is a character. We could have a switch case. No. Fuck. We could. The problem is it's a number, so we want to print the. So we could just print. So we want this to be a character. So I want to convert these guys to, I think 65 is lowercase a. So we could say this minus 65. So we could say $65 currently we could start at 65. And then explain it later, or just say it here. We could say this. We could say, so there's an int minimum enemy, or minimum enemy character int, and the minimum is 65. I think that's what lowercase a is. And then we have current enemy, which is, we'll initialize it to be minimum enemy character int. And we'll say while current enemy is less than or equal to the enemy count plus minimum enemy character int. So adding 65 to take it from 1 to b. What is lowercase? I think that's what is lowercase a in ASCII. Never fucking mind. Oh, what is uppercase? 65. Okay. And the difference is 22? Really? Wait. Oh, 32. 65. So we add 32 because they're like 26 and then all the other things, I guess. So we'll say the minimum is actually 97. And so we get the current enemy count, and we add this to get the character version. And then we will increment the current enemy. Excuse me. And we will output. And we could make this a uint, so it prints as a character. Or we could just print static cast. I think we do. Static cast to a character current enemy. Oh, there's a lot of shit going on here. Hold on. Player attack does not yet have world properties. So we'll put input and output in here. Oops, this needs to be later. Okay. All right. And so we're going to say attack which enemy, and then we're going to print all possible, or print enemy choices. And then after we've printed them, we're going to say standard character input to enemy choice. So this will display those. Or we could say attack which enemy of this, attack which enemy, and then we'll put this, and then we'll do while after. I think we do that instead, actually. Because I don't want to put all that, like if they enter invalid input, I don't want to re-put all of this information there. So I think we instead do attack which enemy, print the enemy choices, and then we say do this while enemy choice is a fucking character. While enemy choice is greater than the total enemies. So while enemy choice, which will be, okay, gotcha. While it is greater than, I think we need 2 parentheses in here. And we're going to add, 97. I think we need this before. So this will be int here. This will be a constant, constant expression int, minimum enemy character int. And this will be plus minimum enemy character int. And this is while it is greater than world properties, current enemy count. Yep, and then we need a semicolon. Okay. So we're saying, which enemy are you attacking? And then this is minimum enemy A is 97 as an int. And we need this in order to convert the numbers of current enemy count into characters. So we have an integer that is current enemy. What do we want a character? Let's see. Okay, so current enemy, the minimum is 97. So we start at 97 for the first enemy, A, while it is less than or equal to current enemy count, so A plus however many. Our current enemy plus this. Oh, but this is going to be, oh, so this needs to be, I think, less than instead, actually. Because the current enemy count, 1 is the minimum. How many enemies are there in an encounter? There can't be 0. So there's 1 enemy. But then 1 plus 97 would get B. So we actually want to start out at so if there's 1 enemy, this is 97. But this would be printing twice. I think we want to say less than here. Okay. And then we'll increment current enemy. So it'll go from 97. Output 97, but as a character. So A. And then, well, let's say there's another one. Okay, so to increment this to be 98. and there are two enemies, so it's 2 plus 97, which is 99. 98 is less than 99 in this case. This is 2 plus 97, so this is 99, but now we're at 98. So 98 is less than 99. So we'll output this, but then we increment it again. Oh, 99 is not less than 99. Cool. We'll print the enemy choices, and then we will get valid enemy choice. Okay, and we do it while we do it until, so we want to do it at least once. And in this case, we don't need this block because this is just one. So we'll just do that. So do this while it is greater, while the enemy choice is greater than this. While it is greater than or equal to. Because if we choose 97 to attack enemy A, and there's one enemy, we want 98 to be an invalid value. So this would be 1 plus 97 is 98. So as long as it is, if this equals or is greater, we don't want it. So you only want it if it's less. So if they say A, it's 97. And the value, and the valid answers are, well, this would be less. So while it is not, we don't want it to be too low either. So while enemy choice is less than minimum enemy character end, because we want it to be at the lowest A, or if it is greater than or equal to it. Greater than or equal to the sum of this. I think that's what we do. While enemy choice is greater than or equal to this guy. So this is 97 plus, this is 97 plus 1, so that's 98. And we want to make sure that we are under that, but not under the minimum, I think. Okay, and at that point we have a valid choice, so we will return enemy choice. Okay, what are the warnings here? Oh, it's just these, it looks like. Okay, so that's player enemy choice, and now player attack choice. This is the CPP file. So the attack choice is which attack to use. And then we'll say int attack choice. And then we can say this should be pretty easy. But then we could also still output it. So we could say which enemy, A through whatever, and then which attack, something through whatever. Do a similar thing. So we could say which attack for int current attack, and we'll say it's 1 while it is less than or equal to, or current attack is less than or equal to world properties. Oops, attack, or is it character attack count? This should be player attack count. Player attack count. Player attack count. Player attack count. Increment current attack. Oops. And then we will output. Oops. Current attack. And then in the line. So we'll start at 1 and then go through it and then output it. So we output each attack and then we'll say do extract input to attack choice while attack choice is less than 0 or attack choice is greater than the total amount of attacks we have, and then return attack choice. Okay. And then player attack will have an integer, or it will have a character, and it will be enemy choice, and it's initialized to be player enemy choice, and then an int that is, and this should be, we'll just say it's const so it doesn't change here, const. So this should be constant character, because once it's chosen it can't change. This is a constant int player attack, attack choice, and it is player attack choice. And then we say attacked enemy choice with attack number attack choice. Okay. All right. And we're going to include, player attack. What else? These already included CPP tools, so those will be transitively included here anyways. I think we just do player attack, maybe? And then we'll just do player attack, player attack. Oh, this needs to be attack which enemy. Boom, boom, boom. Or we could say, so we could say attack which enemy, A, B, C, and then we can say A. Okay, what happens if we did D? D. Okay, it needs to reprompt. So we could say, do this. And this, I think, needs to be, so what would happen if I did that? Nope. Okay. So we want to reprompt here. So we'll say if enemy choice is less than the minimum this guy, so if the attack is too low, or if the attack is too high, enemy choice. I think we just do the same thing here. Invalid enemy choice. Choose again. Okay. And then same thing here. I'll make sure that we're using a valid attack choice. And then we could just say, I think we can just take this same condition. If this. And I think this makes sense because we don't want to just call this whole thing again. Maybe we could. Excuse me. But I'd rather just start here. So say check if attack is too low or high. Then, this is only one thing. Attack choice out of range, choose again. Okay. So we could say A is cool. Oops. And this needs to be the same thing. Which attack to use? And then I could say attack. Boom. Like maybe this makes sense. Attack number or attack that. Or, and then enemy like that. Which enemy? D. E. F. A is good. Attack 5 is out of range. 0 is... Oh! 0 should be out of range as well. Oh, if it's less than or equal to... Whoops. If it's less than or equal to... I had to change that in 2 spots. Is there a way to avoid repeating myself? You could just call the whole thing again. All this. I think this makes sense because we do this. Or we could say do it and then if valid, but I think this is fine. Excuse me. So if we say enemy, let's see. What if we said enemy 97? 98, 99, 100? Okay. We said D C 5 0 3. Okay. This is kind of cool. So you have world properties to store the info. So this could now be, let's say there are only 2 enemy options now. There's enemy C is out of range now. B is not. And 4 is now out of range and 0 out of range. But then we could say the player attack is now, oh, and we could actually update it here. So we could say world properties, current enemy count is now, let's say there's a shitload. There's 8 whole enemies. And then world properties, player attack count is 5. We have 5 whole attacks. Holy shit, we have a lot. Okay, there's a lot of enemies now, all the way through H. I is invalid, but F is valid, and we can use 6 is out of range, 0 is out of range, 5, enemy F with attack 5, and then we could have some way of storing all that info. Okay, that's cool. And this is all basically just to put some things together and use this ignore line. So now, if we did enemy A3 and we didn't do the ignore line, then it would extract A to the enemy choice, which is what it's doing. Hold on. Yeah, we're not calling it. That'll do it. That will do it. Okay. And so we could have a generic integer getter thing, but in this case, I'm just going to do CPP tools. What do we have it? Is it? Oh, it just hasn't been included anywhere. That's why. So we'll say player attack H needs to include CPP tools H. Oops. Need ignore line to clear input buffer. All that talking, I never even used it yet. Unreal. Is it raining? No. Wait. Never mind. Damn. All right. CPP tools, ignore line. Whoops. And not needed here, but well, it could be needed here. Yeah, it could be, because if we called attack choice again, or if we called player attack again, then, and if we put in enemy C, but then we put 5A, we would do enemy, or we would do attack 5, but then when it gets called again, it would say which enemy, and it would immediately extract A. But in this case, we're going to do CPP tools, ignore line. Boom. And now we can say A3. Fuck. Oh, good. Because it only took A, and then now we could say 5. And same thing, we could say again, and then player attack. We could attack a second time. And then we could say E5, and then 5A. And so it took E as the choice, ignored 5, and then took 5 as the attack choice, and then ignored A, and then now I have to choose, and then I can choose B, and then I can choose 3, and I could choose a whole bunch of other shit, and it would still just be 3, and then it would ignore the rest of the shit, and it works pretty clean. The code is very small because we have header files and implementation files. Cool. And we can put these like this. That's kind of nice. I like that. Cool. That was fun. Took a while to think through this stuff, but I think that was a good way of implementing that stuff. Cool. Somehow that was 50 minutes. All right, I'm going to take a brain break for a sec. No, I'm not. Yes, I am. I got to piss.